Welcome to another unit in this Excel course. This time I'm going to talk about the general, let's call this guidelines when working with diagrams or charts. Well, first off, if you want to generate a specific chart diagram, you can go to Insert, and here we have the part Charts. So if you select some type of data, let's say I go here with the 2 exam scores, I can click on recommended charts and he will tell me which he thinks are the ones best suited for this. So here I see it's scatter plots, which he puts on position 1, or column or bar charts, and only afterwards he proposes some other things which in the end turn out to not be so well of a choice. However, we can also select our own charts. For this, however, we need to keep in mind or ask ourselves, how many dimensions do we actually have in our data set? How many dimensions? What do I mean with dimensions? Well, here, if I consider these points or the marks I get as coordinate 1, coordinate 2, might make sense to interpret them as two-dimensional data. Two-dimensional data I can easily express in a two-dimensional fashion. So I can easily express this, for example, here in a scatter plot. I could also go with the column chart or the bar charts because they offer chances for more dimensional aspects. So I could have different things next to each other. So I could go with 3, 4, 5 dimensions. However, if I go back to all charts, wouldn't make so much sense to try to illustrate this with some kind of pie chart. This would just look strange. The same thing goes if I were to go with areas or the more sophisticated versions like tree maps, sunbursts, even histograms. So this will just look strange. On the other hand, box plots might again make some sense. But this is always the question with dimensions. So some of those, like the pie charts, they're well suited for one-dimensional data sets. One set, few observations. That's the next thing. How many observations do you have? Also, to keep in mind, do we have more or less cross-sectional data? Here we have it. It's different people we observe. Or do we have longitudinal, so time series data? Because when you have cross-sectional data, something like column charts, bar charts, or even here scatter plots, they make more sense. If you have longitudinal data, time series data, I would always go with either line charts or area charts. Because then you directly see more or less the temporal development. So keep in mind which type of data you're using, dimensionality and type of data. That's really critical, and best not to try to actually, combine different types of data. Well, if you're not so sure, one way to go could be different, what they call here radars. They are also in some cases called spider diagrams or spider plots. And this writes like a surf or more or less an outline for the 2 exams. And then I can directly compare them. Is one of them inside the other, outside the other? So this is a nice way if you have a lot of observations and want to compare, like here 2 variables, 3 variables, but this is actually limited again by the dimensionality. If you determine dimensionality via variables, if you determine dimensionality via the number of observations, this is actually no problem. Here, as you can see, I have 19 observations, so 19 different points on my circle. So this works if you interpret this correctly. So the choice of the correct chart is in some cases also up to how do you actually present your data. That's something to keep in mind, because in the next few units I'm going to explain a lot of which data can we use, how can we actually change this, what can we do with this. The problem, however, is you, before you use anything else, need to make sure that the data is actually, or the chart type is actually suited to represent your type of data. Well, with this, let's call this recommendation, this word of warning, I can already conclude this introductory unit on working with diagrams, working with charts. Well, that's it. So goodbye and see you in the next session.